All right, next up, I'm very excited to introduce John Yuksel, who'll be taking us through OpenUSD and Omniverse and Houdini. Over to you, John.
Thank you.
Welcome.
All right. Hi. Welcome, everybody. Thanks for coming. And we're coming to the end of SIGGRAPH on late afternoon Thursday. Thank you for being here. I am John Yuksel. I'm a senior graphics engineer at NVIDIA. Today, we're going to be talking about our procedural content generation framework for scaling simulations with Houdini, OpenUSD, and Omniverse. Drive Sim is NVIDIA's large-scale, physically based, multi-sensor simulation environment for autonomous driving. And the work that I'm presenting today is a team's work for Drive Sim Content Group, and I'm proud to be a part of it. All right, so what we're going to present today is our Omni-Houdini procedural library. There are 4 key pillar elements that we want to have in our library. That is data-driven and multi-component shareable Houdini-based procedural assets. We want it to be composable. We want it to be flexible for sharing. It needs to be data-driven, and we need to be scale with this representation. And we would need to have some way to have the HDAs to be represented in a non-centralized fashion, which I will get in detail. So here's the outline of the presentation. First, I will have a very high overview of what OpenUSD and Omniverse is. Then we're going to talk about our data-driven procedural asset system. Then we're going to show the workflow of this system, and we're going to present that in our use case, which is NVIDIA's Drive Sim. All right, so here is a very broad explanation of Omniverse. I'm assuming people in this audience will have some understanding of what Omniverse is. So Omniverse is not a tool, but a platform. And as well as USD is not just a file format, but a framework. Right? Omniverse is a development platform that connecting 3D applications that is running with the OpenUSD. And this platform enables the applications to have a broader level of communication. If you think about it in the pipelines that we are familiar with both in visual effects and engineering, tools have their own IOs, and these IOs will generate a very fragile, cumbersome pipelines to put together, and it generates somewhat of a streamlined, serialized workflows. But with this Omniverse platform, everything running in conjunction in OpenUSD, it allows a parallelized approach as well. It is already being used in ecosystems for our giants like Autodesk and Adobe and Siemens and Epic Games for their ecosystem. And our software partners are constantly writing new applications and softwares to enrich the Omniverse experience every day. And our customers like BMW Group or Amazon Robotics are bringing their own data and writing their own custom applications on Omniverse to enable their employees to do their complex work. And USD is, again, I believe, something that you are all somewhat familiar with. USD is the foundation for Omniverse platform. So what USD is, it's a formatted, it's been pioneered by Pixar, has been used in their movies to make their complex worlds in visual effects for many years before it became open source in 2016 for everybody's use and become OpenUSD, hence the name. It has been a platform that enabled the Omniverse. So what USD is an open scene format with an API that allows you to do editing and querying and rendering. This platform can actually utilizing the USDs in this fashion. And this representation is efficient, it is scalable, it is sparse, and this non-destructive authoring workflow of it is very tailor-fit, not only, but not limited to, but mostly for visual effects work and design and engineering, right? And very recently, it's been announced in the beginning of this month, there has been an alliance been announced between Pixar and Apple and Adobe and Autodesk and NVIDIA for an alliance for OpenUSD to further utilize and unify the workflows and foster development and accelerate the adoption in the industries. So now going through this basics, let's talk about a simple scenario where we're going to present our stuff. So here is a picture of a real world place in real world in San Jose. And imagine we are in the problem of generating some content, right? In a conventional HDA approach, you will have HDAs that is predefined for particular functions. And imagine in a content creation problem that you will have some components that you need to create. In this simple example, there are some curves that's representing some features from the real world, like sidewalks and ramps and islands and other parts being represented with different colors, right? And you will have specific HDAs that actually takes this information with the interface that you put the values you put in, it will execute this function and generate the content, which is a familiar workflow for us all in content creation. But for our needs of shareable and flexible and scalable workflow, we have to change the way we approach this interface. Because of the complexity of the content that needs to be created with multi-parms and randomizations, what we're having is very complex interfaces and hard to version and scale and collaborate. What we have envisioned to do is to separate and decouple the interface from the HDA so that the parameters, the entities that represents the topology and geometry that you need to create is separated from the function. So HDA becomes just a function, and the representation of what that needs to be becomes a USD file. It's called template. So let's look at the real-world examples of one of the contents that we're creating, barriers, and appreciate the complexity that needs to be represented in the real world. It comes in different shapes and topologies and colors and representations that needs to be captured in our execution. So the interface in our representations becomes a template like this. A template is like a recipe that tells you, has some common attributes like any content in this scale would have, like a width or the height or the terminals. And this representation is a recipe to put together a barrier definitions. And because it is a natively USD file, you can load this USD file in Omniverse, and they become like a rendering parameters, and you can change these values the way you wish. The moment you have an instance of this template, put some values on it, have a representation, that becomes a preset that allows you to build something like a fence. So these instances from this template class just allows you to represent the barrier in a different ways. The function under the hood will take these presets and build it for you. So imagine the ARM code is still using this template with different values. Or you can have a combinations of these things. So at that point, the presets that representing these complexity of the world is on the data itself. And the HDAs end up being just a function that takes that and executes it. But leveraging that notion and pushing it further, also the templates that represents the barriers can also be a function of other templates. So imagine that you have a more atomic templates that is shared upon all contents that you create. Like something about its position, something about its randomization, something about its terminals. That can be shared with other contents like crosswalks and roadways and poles. So you use these more atomic representations to put together the template that is the barrier, so that everything is defined in this structure. Imagine at some point you need some unique IDs, and in this world of real world, even 64 bit integers is not cutting for you. You need to switch to some of a string representation. You need to define this in one of these templates, and everything inheriting from this template will automatically be utilizing that. So till this point, we focused on only the template, the representation of the recipe. But how was the rest of the procedural asset generation happening in Omniverse, right? So the thing that is responsible of the function is coming from the OmniGraph. The graph structure of this procedural rig is what it does is has some native nodes that takes the USD information and feeds it to the HDA, the function that generates the data, the topology, and feeds it back to the USD back again to be in the live on stage. So this is a graph that executes on runtime. And this whole procedural asset itself becomes a packageable, versionable representation of this asset saved as a JSON file. Here is how that actually looks in the context of Omniverse. In the Omniverse representation, there is the graph, and the graph has the HDA in it. And it has some native Omniverse graph nodes that connects these things together. Having this already be in the platform connected with the native Omniverse nodes allows you to be able to further utilize some of the functions that come with Omniverse to filter the assets, further enhance the topology, do the things you need to do. So what you see in the live view of different representations and executed in the live stage as different types of barriers. And here is a picture from the asset library that defines these different types of barriers that the user is allowed to drag into their scene and then apply it into the pieces of data. So just want to show a simple animation that shows the workflow in live in Omniverse, that you can have a curve that you've generated, and you can drag one of those representations to your scene. After you have it in your scene, you can apply it to the curve, and this graph will execute it and run the HDA and have this topology in your scene. Because it's happening on runtime, these things are linked. This graph is the running action. So when you have actually make changes to your values, you will see interactively the content generation will responding to that. So now I'm just going to dive into some USD settings in the parameter and showing that it's actually dynamic. We'll make some changes and you'll see that updating on the live view. Cool. And this workflow also enables a cloud representation. So the asset library that you have defined can be held in cloud and in Nucleus. And you can pull these asset representations in your local session in Omniverse and build these graphs and also kick the computation to the cloud as well with the Omniverse services. So this allows you to be both the cloud for both the storage and the computation, but keep the services on your. Till this point, we have focused only one aspect of content creation, which is barrier. But that is not the only thing we're doing. I just want to give it a little bit of an overview of what we are trying to put together. The images you have seen here is a brief representation of what we do. In our OmniMap2Sim pipeline, we are taking raw sensor data, and those sensor data has been extracted to some vector representations with semantic information on it, and these representations are fed to our content creation to be sim ready. Here is the graph representation of what we do. There is some survey cars that goes around the world, connect some raw data. This collected raw data becomes an HD maps fed into our pipeline as OmniMap. And we generate a bunch of content. We talked about barriers, but we make roads and road markings, lights, and all sorts of other components that makes the autonomous driving possible. And these scenes will become a simulation ready in our pipeline. and it's been fed to solvers. And Drive Sim has been the main simulation here, but just keep that in mind. Our simulation-ready content is not limited to a perception. We're not generating 3D worlds for just to be rendered. These are also being used for simulations, not only physics simulations, but also sensor simulations, like the LiDAR and the radar. And another important aspect of the asset creation workflow that we get ourselves in is that we're not generating static assets. The world we're creating also has to be able to randomize its content for scenarios. So in our offline processes, we take these curves and we generate our content with our OmniMap2Sim pipeline, but then the sim content is fed to Drive Sim on runtime, and with our API, we are allowed to make variations in the assets. Because generating a scene is a big deal, and once you have a functioning scene with intersections and everything, it is very valuable to be able to verify the sum of the different variations of the world to further train your algorithms. So I just want to show, I'm hoping that it's going to run smoothly, an example of our Drive Sim execution. So it all starts with the collected survey data, and then the features is extracted from the survey data, and procedurally generated content is further enhanced with the 3D generated content together to make one of our complex seeds that we showed us in our GTC demo. And here is a simple snippet showing that it's also running a real-time radar simulation. All right. So let's give it an overview of what we talked today. There are 4 key pillar things that we want to maintain with the way we build our procedural asset library. We need to build assets that we can compose together and make complex structures. We need something that is shareable, that can be used, that is data-driven, because data will be the thing that dictates the complexity of our world, and it needs to be scalable and performant. And we also show that this system is functioning in our OmniMap2Sim pipeline under Drive Sim currently. And the third point is, of course, is the big takeaway for whoever will be interested, is that under Omniverse ecosystem, this framework will be available for anyone to use in their own projects to have this procedural asset library representation. That's it. Thank you.
Super cool. Any questions? Questions? Yeah. You want to hand? Nope. Hold on. Just one second.
At any point, do you ever collapse the data so it's not live anymore to the curves, or do you always leave it live and to edit it later?
That's a great question. Thank you. In the context of being variable for different scenarios, it has been kept live. But of course, to have it in the performant versions of these things will require it to be flattened to execute it in the fast. So you have to make some decisions around a performance scene versus a variable scene that can be represented in different scenarios. And there was a version of it that is more flattened, and now the world is going around making different versions accessible immediately. So currently now.
So do you have separate tools to collapse all that down, or?
There are different tools to make that a flat representation that is more performant to be executed.
Any other questions? Yeah.
So when you were talking about like interfaces versus function and describing HDAs using that, I want to know like what these interfaces look like. They kind of look like USD schemas, but you said like you can use atomic templates to form like a new template, and that was a cool concept. So like, what is it?
That is, on itself, it is not a schema. It is using native USD files. It is not using a special schema, but there is definitely a structure in hand to understand that notion as the format and builds upon its inheritance. So it is not utilizing a schema to build it. It's a convention that we build together to get that. So it is getting from the context itself that, okay, this is an inheritance from that, and builds a structure.
Do you see adding that to the actual USD library? If like this is like a convention set, do you think like it should exist in the actual USD, like vanilla USD, or like?
It is a compromise the moment you make a schema of your thing that you are getting specialized and detaching yourself from the broad chain of tools and utilization, right? The framework. But it is definitely a conversation. It is definitely a thing to be able to say, yes, that will definitely be functioning more streamlined if it will be its custom thing, for sure.
Cool. Thank you.
Thank you.
Hello. On the feature extraction point, which tool do you use? Is it Omniverse, Houdini, or is it something else?
NVIDIA have joined with a company called DeepMap about a year and a half ago. And DeepMap is a map generation company that takes survey data and extracts these features, and they have their own algorithms and users to be able to extract the features from survey data. So that is happening before it feeds to our pipeline. So it's extracted. That is that OmniMap2Sim USD file that comes into our pipeline.
Okay, thank you.
Sure. I clicked my thing because it has DeepMap says on it, so that was the connection.
Other questions? Yeah.
Can you talk a little bit more about your HDA structure and how you're bringing your like what's going on inside of it when you feed it the curve and the USD template?
Yes. So it is a JSON file that keeps the versioning of which versions of HDAs and which types of it needs to be loaded. So the moment you have an update in your template and how the data needs to be structured, that has a corresponding HDA version. So they are tied together so that one change and one representation difference will return a different HDA, but the function stays the same. So the presets, the things that you generate things with, doesn't require a change in the HDA. So the HDA version can stay the same while you're building the complexity. But if you will to change some fundamental representation of how that context put together, that requires, of course, an update in the HDA as well. And the JSON file is the thing that sets which HDA is connected, which versions of template.
Thank you.
Thank you.
What size survey data sets have you been using, like, scale-wise, cities, block?
The content we have generated for the GTC, the thing that I've shown in the demo, is about 2 kilometer to 2 kilometer wide range. But the survey data itself is immensely loaded. It is gigabytes of LiDAR data, but it's been accumulated together in the ways that we are not directly had to be exposed with. What we are receiving is extracted simplified vector representations that is in the USD, and they are very light, under a megabyte simple USD files.
Anyone else? Yeah.
Is this pipeline or some of the tools available somewhere?
It will become available. It will be announced under Omniverse. It will be available soon, but yeah, not currently available for use.
Thank you.
Thank you.
Any final questions? Yeah.
This probably relates to a couple earlier questions, but the idea of USD templates that parameterize HDAs is a very powerful concept and obviously forms the basis of a lot of what you're doing here. I think, is that concept something you have to roll yourself in USD, or is there some reference that's provided through these materials that you could sort of like follow that to develop something in your own pipelines?
That's a great question. Thank you. With the release of this framework, we are already publishing out some blog pages that explains the processes, but we will definitely get into more in-depth as documentation of how these things can put together. But having that, not requiring a special schema to build in the USD structure natively, should allow a very easy conversion to your systems.
Excellent. Thank you so much. I look forward to that.
Thank you.
Terrific. Well, thanks so much, John.
Thank you.